Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss about variable size partitioning in detail. So I request everyone to watch the complete video for better understanding. In the last video, I have discussed about the fixed size partitioning and its limitations. Let me give an overview about them. One is that internal fragmentation, external fragmentation, restriction on number of process and restriction on process size. In fixed size partitioning, the number of partitions are fixed and size of each partition may be same or different. Okay, let me give with an example. Let's consider that main memory size is 64 MB. Okay, out of the 64 MB, operating system has occupied 32 MB and the number of partitions are fixed as 4. Let's consider that partition P1, partition P2, partition P3 and partition P4. Okay, and let's assume that the partition size may be same or different. Let's consider that each partition size is different. 16 MB is there, 4 MB is there. Okay, and this is 4 MB and this is 8 MB. Is it clear? Are you able to understand it or not? Now, why there is a restriction on number of process? If you look at the number of partitions are 4 and it is a contiguous allocation. The both fixed size partitioning and variable size partitioning comes in the category of contiguous allocation. What is meant by contiguous allocation? A process can be allocated in any one partition. The spanning is not allowed. A process cannot be there in multiple partitions. So, if we can allocate one process in one partition, if you have 4 partitions, maximum we can have 4 processes. If we have only 4 processes, then there is a restriction on the number of processes. So, the CPU utilization will affect. And restriction on process size. Let's take that you have a process P2 whose size is some 20 MB. Let's consider for an example. Now, if process P2 of size 20 MB, does we have any partition of size 20 MB? No, we don't have any one partition of 20 MB. Then you will say that sir 16 MB is here, 4 MB is there, combinedly if we make it will be 20 MB. But it is a contiguous allocation. In a contiguous allocation, we cannot keep any process in multiple partitions. So, even if we have 32 MB of space, even if process P2 of 20 MB comes, we cannot allocate it. So, there is a restriction on process size. Now, we will discuss about the internal fragmentation. Let's consider that a process P2 of size 8 MB occurred. Okay, now that has been allocated in the partition P1. The partition P1 size is 16 MB. Out of that one process P2 we have kept. So it is 8 MB. So remaining 8 MB space is free. So this space we cannot use it for another process. Okay, so that's why there is an internal fragmentation. We are wasting 8 MB of space, which is an internal fragmentation. Now let me discuss the external fragmentation, why it will occur. Let's take that process P2 has 8 MB. Another process, let's take that P3 whose size is 2 MB is there. So here you have 8 MB free space. Here you have 2 MB free space. Let's take that process P4 came 4 MB. There is no free space. Process P5 came 8 MB. Okay, even here and here there is no internal fragmentation, but here and here there is a free space. The total free space size is 10 MB. Let's consider that a process P5 whose requirement is 10 MB. Can we keep the process P5 some part in the partition P1 and in the some part in the partition P2? That is not possible. Contiguous allocation should be there. Even we have 10 MB free space, a process P5 came with 10 MB, we cannot allocate. So this problem we will call it as external fragmentation. So these are the limitations are there in the fixed size partitioning. Now we will discuss about the variable size partitioning. How many limitations will be overcome? We will discuss now. Okay. In variable size partitioning, there will be number of partitions will not be fixed. There is no partitions at all. Is it clear? Are you able to understand? We have the main memory. Okay. And then we will have the operating system. So let's consider that you have a main memory of 64 MB. Out of that one, operating system has occupied 32 MB. Then remaining 32 MB we will not divide into any partitions. This 32 MB will be there like this. Okay, suppose let's take that a process P1 has come with 2 MB. Then 2 MB of space will be allocated for the process P1. Does we have any internal fragmentation? We have made it into a one partition of size 2 MB whenever there is a process came. So at the runtime we are allocating that memory. So there is no internal fragmentation because we are not wasting any space, because this 30 MB remaining thing we can use for any number of process. So there is no internal fragmentation in the variable size partitioning. Is it clear? Are you able to understand? Now we will discuss about the restriction on the number of process. Here in the variable size partitioning, we are not dividing into fixed size partitions. Am I right or wrong? There is no restriction on how many partitions we have to do. So if there is no restriction on the number of partitions, there is no restriction on the number of process also. This limitation also overcome in the variable size partitioning. Now we will discuss on the restriction on a process size. Now let's consider that main memory size is 64 MB. Operating system has occupied 32 MB. Then the remaining size is 32 MB. So if a process P5 comes with 32 MB, we can allocate this 32 MB for this process P5. So let's assume that process P6 has come with 64 MB. Now can I allocate the 64 MB for this process P6? The main memory remaining thing is 32 MB. If we have only 32 MB, how can we allocate the 64 MB for a process? So still there is a restriction on process size, but that limitation is little bit reduced. How I can say, if it is a fixed size partitioning, if the size of each partition is fixed, then there is a restriction on the process size. But however, in the variable size partitioning also that limitation is there. That limitation depends on the size of the main memory, not on the size of the partition. Is it clear? I hope you are understanding it. Now let me discuss about whether the external fragmentation is possible or not. Let's consider that we have 32 MB. A process P1 came with 16 MB. Then a 16 MB will be allocated for the process P1. Okay, then we have another 16 MB. Let's take that process P2 came with 4 MB. Then process P2 will be allocated 4 MB. Now process P2 with 4 MB. Let's take that another process P3 came with 2 MB. That also we can allocate. Now process P4, okay, has came with another 2 MB. Okay, we have allocated. So how much space has been allocated? 16 plus 4 is 20, 20 plus 4, 24. We have another 8 MB. Let's take that process P5 is 8 MB. Okay, we have allocated process P5 8 MB. See, even in the variable size partition, it should be contiguous allocation. So entire 8 MB should be allocated continuously. Okay, now let's take that process P2 has completed its task. Okay, so it has been removed from the main memory. So there is a hole of 4 MB because it is free space now. So this concept we'll call it as a hole. Okay, let's take that process P5 has completed its task. So there is a hole of 8 MB. So how much free space is there? 12 MB is there. But whether the free space is continuous? No. Let's consider that a process P6 came with a requirement of 12 MB. Now, if you look at here, the whole size is 4 MB. This whole size is 8 MB. So the total free space is 12 MB. But can we allocate this 12 MB to this process C6? No. Why? Because it should be contiguous allocation. There should be no spamming. Meaning is that 4 MB of the process P6 we cannot keep here, and remaining 8 MB is not possible. Are you able to understand? So there is an external fragmentation will be there in the variable size partitioning. Now, how this can be overcome? I hope you are understanding, because even we have 12 MB of free space, the process P6 came with a requirement of 12 MB. We could not able to allocate because it is a contiguous memory allocation. A part of the process P6 cannot be kept here, another part we cannot keep here because it should not, spanning is not allowed. It is a continuous allocation. So now what we can do? There is a technique called compaction. Okay, in the compaction, what they will do is that, okay, you have a process P1 of 16 MB, there is a whole of 4 MB, this process P3 is 2 MB, this process is 2 MB, here you have a whole of 8 MB. Now, can we make all the process at one side and all the holes one side? If we do it, what will happen? Okay, you have a main memory and you have the remaining space is 32 MB. If I make process P1 16 MB here, process P3 2 MB here, process P4 2 MB, then this entire whole size will be 12 MB, because this 4 MB, this 8 MB, if we combine at once, it will become 12 MB. So this concept we'll call it as compaction. If we do the compaction, if a process P6 came with a requirement of 12 MB, we can allocate that entire whole for this process P6. But there is a limitation with the compaction. It is a very complex process. Is it clear? I hope you have understood why there is an external fragmentation in variable size partitioning and why the compaction is a complex process, because we have to keep all the process at one side and all the holes in one side. And another problem with the variable size partitioning is allocation and deallocation is very difficult. Why? We have to keep track on the holes. Is it clear? Here there is a hole of 4 MB. Here there is a hole of 8 MB. So we have to keep track of these holes and then we have to allocate. Suppose let's take that a process P5 came with a 4 MB requirement. Yes, can we allocate the process P5 in this 4 MB? Yes, because it is this requirement is 4 MB only. We have a continuous 4 MB free space, so we can allocate. But how we can know that if there is a information about that in this memory we have a 4 MB free space and in this memory we have a 8 MB. If we keep track that one, then allocation and deallocation is possible, but it is a complex process. I hope it is clear for you about the variable size partitioning and why there is a limitation called external fragmentation, what is the compaction and why it is a complex process. I hope it is clear for you. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. In the next video, I will discuss about allocation strategies such as first fit, next fit, best fit, worst fit. All these concepts I will discuss for you. If you want to learn them, please go and watch the next video. Thank you for watching the complete video. Have a nice day.